This video will go over some specific aspects of compound interest, including zero coupon bonds, annual percentage yield, and present value. Recall that the formula is F equals P times 1 plus I to the N, and F is the future value, P is the present value. I is the rate over the periods per year, and N is the total number of compounding periods, or the number of years times the number of periods per year. We'll start with the zero coupon bond. For this type of bond, there are no interest payments throughout the life of the bond and a single payment at maturity of the bond, and that is calculated by interest compounded semi-annually. So example 1, you buy a 20-year zero coupon bond with rate 7.5% for $8,000. What is the face value of the bond at maturity? We'll round to the nearest dollar. And we'll always round at the end, so use the calculations throughout. So here the principal is $8,000. The rate R is 7.5%. The number of years is 20. And we know that since it's a zero coupon bond, it's interest compounded semi-annually. So that means 2 times per year. And we are finding the face value at maturity, which is the future value. So we're finding F. Okay, so first we need to find I and N. I is the rate, which is 0.075, divided by the periods per year, which is 2 because it's semi-annual interest. So I is 0.0375. We also need N, which is the number of compounding periods, or the number of years, which will be 20, multiplied by the periods per year, which is 2. So that gives N equals 40. And now we have all of the information for the equation. So F equals the principal P, which is 8,000, multiplied by 1 plus I, which is 0.0375, raised to the power N, which is 40. Which is approximately, if we round to the nearest dollar, 34,883. The annual percentage yield is abbreviated APY. It's also known as the effective rate, or R sub E. This is the simple interest rate associated with a certain type of rate with compound interest. So the effective rate of what would happen after 1 year in the simple interest formula, given the information used in the compound interest formula. So the way we calculate it is R sub E, the effective rate, is equal to 1 plus R over M raised to the n power minus 1, where R is the interest rate and M is the number of times compounded per year. So example 2, find the APY associated with 4% compounded monthly. So the 4% means that the rate R is 0.04. Compounded monthly means 12 times per year. So M is equal to 12. So now in the formula, the effective rate, RE, is equal to 1 plus 0.04 over 12 raised to the 12th power minus 1, which is approximately 1.0407 minus 1, so 0.0407. That means that the APY, if we rewrite this as a percentage, would be 4.07%. We've used the equation so far f equals p times 1 plus I to the n in order to calculate the future value f. If we want to find the present value or the principal value p, then we could rearrange this equation and divide by 1 plus I to the n on both sides. That would give the equation p equals f over 1 plus I to the n. The reason this would be useful is, let's say that a certain amount needs to be saved in a certain amount of time, then you can determine what your initial investment needs to be in order to meet that goal. So for example, a company needs to save $40,000 for a new building in 5 years. How much needs to be invested in an account now with interest rate 3.5% compounded quarterly in order to meet this goal? So in this situation, we have a future amount that we need of $40,000, and we want to find the principal amount needed. Okay, let's start by finding I, which is equal to the interest rate, which is 0.035, divided by the number of compounding periods in a year. Since that's quarterly, the number of periods is 4 periods. So I is 0.035 over 4. And then n is also needed. This is the total number of compounding periods, which is the number of years, which is 5, multiplied by the number of periods per year, which again is 4. So n is equal to 20. You might notice that this time I left I as a fraction instead of calculating it out. That's to prevent early rounding. So now using this new present value compound interest formula, we set up P equals the future value, which is 40,000, divided by one plus I, and I is 0.035 over 4. That whole denominator raised to the n power. $33,603.85 would need to be invested now in order to reach the goal of 40,000 over the 5-year period.